Server-driven mobile applications have a unique challenge. While the device is offline, the user may be still updating data that they originally sourced from a server. Now, when the device reconnects, on writing the update to the server, if we discover the server's object has also been updated by somebody else, which update wins? In this video, we're going to look at the Oracle Mobile Cloud Service data offline and sync capabilities, specifically around handling data updates and offline writes. G'day, I'm Chris Muir from the Oracle Mobile Platform team. Let's explore some of these issues in more detail so you understand what the problem is and why a solution is needed. So imagine an MCS from an external server. We've fetched a collection of objects and stored it in an MCS to be used by one of our mobile applications. Now this could be files, Word documents, JSON documents, whatever. Eventually, along comes our mobile application and pulls down the objects locally so our mobile user can see them. And at some point, our mobile user on that device may create, say, a new object or update or delete an existing object. Upon saving the change, the mobile application, if online, can happily send this change to MCS. If it's a new object, MCS can easily create it. If it's an update or a delete to an object, MCS can apply the change to the original copy of the object on the server side, and everything is fine at this point. Now, imagine exactly the same scenario. The user is updating one of the objects on the mobile client, but this time the mobile application is currently not connected to Wi-Fi or a cellular network. It's effectively disconnected. In this case, on the client, once we save the object, what happens? We can't write the change to the server as we're currently offline. Ideally, what we want is a solution not where the updates are stuck forever on the client or lost totally, but where the offline updates are queued such that when the device comes back online, the updates are written for us to the server, and ideally automatically without any programmer intervention. This is the concept of updates and offline writes. While we're at this stage of the explanation, it's a good point to highlight a further challenge about writing updates to the server. Regardless, when the objects are updated in our mobile app, online or offline, eventually, hopefully, our objects will be written to the server. Now, what happens if, say, meanwhile, a second mobile user with the same app has downloaded the same objects and they've updated the object we wanted to update? Firstly, how do we detect the collision? Then, should we overwrite the server change so our client update wins? Or should the server's updated object overwrite our mobile's object so the server's update wins? Or even, should neither occur? Maybe we preserve the conflict and we give the mobile application a chance to resolve it programmatically. So with these examples out of the way, you now know about two powerful features that will save mobile developers from very complex programming problems, known as offline updates and the facilities for collision detection and resolution. For the remainder of this episode, we will focus on offline updates, and we'll cover collision detection and resolution in more details in the following episodes. So, the data offline and sync API's offline update features provide the ability to define, via sync policies, how you want to handle the updated cached object to the server and how they are synchronized, of course, back to MCS, with, here we go, little to no code required from you, the developer. As we saw in the earlier episode on sync policies, for each API you may set the update policy, such as this example from iOS, where I've set it to queue if offline in the OMCP list file. Each supported mobile platform has a very similar policy and set of options. Now, update if offline is the default option. If the application creates, updates, or deletes an object in the cache, this option will attempt to push the object straight to MCS, assuming it is online and connected. And if offline, it will throw an error for the developer to resolve. The opposite of this, and much more sophisticated option, is the queue if offline option. Now this will similarly write newly created objects, updated and deleted objects to MCF if the application is online. But if the device is offline, it will queue these changes, wait until the device returns online, and then will automatically send them to MCS on the developer's behalf without any programming intervention. As I always like to say, it's handled automatically for you. So questionably, how do you create, update and delete objects in your mobile app? What does this source code look like? In this iOS Objective-C example, I've set up the required initial sync objects in the code example at top. Remember, you only need to do this setup once in your application, but I've included it here for reference in this example. Then, via the OMC mobile endpoint instance that we've created, we either fetch down a collection or an object to modify, or as I wanted to show you in this particular demo, I've created a new OMC mobile object. From there, in this example, I happen to know that I'm working with a JSON object, so I use the add or update JSON property method to update one of the object's properties. Next, I call the save on resource and success method, upon which either the success or error callbacks will subsequently called after the record is saved to MCS. Though this example just covers iOS, the Android and Windows SDKs have very similar functions too. Refer to the relating code docs for the specifics for your specific mobile platform. What is important here though to note is that in this example, like other episodes, is what I don't have to do as a programmer. I'm not bothering to detect if the app is online or offline in code. I don't have to manage the offline queue of updates or writing them back to MCS when the app returns online. The SDK takes care of all of this for us. Stick with us in the next episode. We will now drill into how, when writing the updates to the server, we will deal with update conflict detection and resolution.